Okay, in 5.9, we are connecting f prime and f double prime now that we have found a purpose for f double prime and f prime. But first we're going to revisit the previous chapter when we talked about velocity and acceleration. Because remember, if you know position, velocity is the first derivative of position, and a of t would be the second derivative of position. Okay, if you remember, an object is speeding up if v of t and a of t have the same sign. It's slowing down if v of t and a of t have different signs. And we've already talked about this, but now we're going to think about different ways to organize our information so it's easier for us to tell what's happening. Okay, a particle is moving along the x-axis with the position function x of t equals 1/3 t to the third minus 4t squared plus 12t. Describe the motion of the particle. Okay, let's see what the particle is doing. So first let's consider v of t. How do we get v of t? V of t is the first derivative of position because I want to see the distance with respect to time. Okay, so the derivative of 1/3 t to the third, bring down the 3, lower it to t squared minus 8t plus 12. Okay, now let's consider the critical numbers with respect to velocity. So let's set this equal to 0. Did they give me units? No. At t equals 6 and t equals 2, the velocity is 0, which means it's probably changing direction, but something important is happening at t equals 6 and t equals 2. Okay, now let's also consider the acceleration function. If I want the acceleration, that's a derivative of the velocity function, and I just found the velocity function over here. Okay, so let's take the derivative of this. Okay, let's set this equal to 0. Okay, so t equals 4 is also an important number. Okay, t equals 4 is my potential point of inflection. Concavity is changing, the acceleration is changing. So now let me consider this function as a whole. I know something important happens at t equals 6, t equals 2, and t equals 4. So one way to keep track of this information is to kind of make one of those little number line things and compare the information. So let me put it in order though. So if this is t, 2, 4, and 6, then I'm going to consider the motion of the particle at different points at each of these intervals. So what should I look at first? Let me look at the velocity first. Okay, so if I'm looking at the velocity, if I'm between negative infinity and 2, let's say I'm at 0, because that's always easy. 0 minus 0 plus 12 is 12. So the velocity is positive below time 2. Okay, between 2 and 4, let's consider 3. I'm going to plug it in factored form because 3 minus 2 is positive 1. 3 minus 6 is negative 3. Negative times positive is negative. Okay, between 4 and 6, let's think about 5. If I plug it in factored form, 5 minus 6, negative. 5 minus 2, positive. So this is still negative. And if I go higher than 6, maybe 7, positive times positive, positive. So I know that this particle is moving to the right until t equals 2, then it moves left until we get to t equals 6 and moves right after t equals 6. Now let's consider the acceleration. Okay, so if I'm lower than t, say I'm at 0, 2 times 0 is 0, minus 8 is negative. If I'm between 2 and 4, think about 3, 2 times 3 is 6, 6 minus 8 is negative. Between 4 and 6, maybe 5, 2 times 5 is 10, 10 minus 8 gives me a positive acceleration. And if I'm higher than 6, I'm big, minus 8, I'm still positive. Okay, so now that I have all this information, I just want to describe the motion of the particle in terms of speeding up and slowing down. So the particle is speeding up if the velocity and acceleration have the same signs, which would be between 2 and 4. And from 6 on. So let's see. Particle is speeding up. On which intervals? From 2 to 4. And from 6 to infinity. The reason? Because velocity and acceleration have the same sign. Okay, and then when is this slowing down? It's slowing down when velocity and acceleration have opposite sides. So from negative infinity to 2, and from 4 to 6. Okay, reason, velocity and acceleration have opposite signs. Okay, now let's consider how else we might use f of x, f prime of x, and f double prime of x. Okay, normally f prime of x tells us increasing or decreasing of f of x. The second derivative is going to help me figure out concave up and concave down. In this case, they have only given me a table with the values of f of x. What do they tell me? F of x, f prime of x, and f double prime of x do not change signs. Okay, now they didn't give me a lot of data, but since they tell me it doesn't change signs, this is going 1, 2, 4, 7. They mean it's not going to go all the way back to -5, or it's not going to do anything weird. Okay, so let's consider these questions. The first one it asks, is f of x increasing or decreasing? Okay, so as the x values are increasing, the y values are going up. It's 1, it's 2, it's 4, it's 7. So the y values are increasing, so f of x is increasing. Why? Because I can see the numbers getting higher. 1, 2, 4, 7. Okay, now the next question is f of x concave up or concave down? Okay, now concave up and concave down, I normally look to see if f double prime is positive or negative, which really means I want to see if f prime of x is increasing or decreasing. So let me just think about f prime of x. How is f of x increasing? Okay, so from x equals 0 to x equals 1, this is going up 1 per 1 x unit. Okay, from x equals 1 to x equals 2, now the f of x is increasing by 2. From x equals 2 to x equals 3, now f of x is increasing by 3. Okay, so this is like, well, it's not really my f prime of x, but it's my average rate of change from 1 to 2. So my average rate of change is going up by 1, then it starts going up by 2, and it goes up by 3. So it's definitely increasing. This is increasing, but it's increasing at an increasing rate. Because it was going up by 1, now it's going up by 2, now it's going up by 3, which means that f prime is increasing, which tells me that f double prime must be positive, which tells me concave up. Okay, now the question is f speeding up or slowing down? Okay, well, normally we see if v and a have the same sign. In this case, we want to know if f prime and f double prime have the same sign. Okay, well, f of x was increasing, so f prime is positive. F prime was increasing, so f double prime was positive. So they do have the same sign, which means f is speeding up. Does it ask me why? If it asked why, it would be because f prime and f double prime have the same sign. Although in this case, they are both positive.